Students, till now we have studied eigenvalues, eigenvectors, diagonalization in 2 cross 2 as well as 3 cross 3 matrix, right? Now let us see few application based problems. Now, if the position of particle moving in a planar force field, if we consider a particle which is moving in a planar force field, right, then its solution is given by the general solution to the system of linear differential equation x dash is equal to ax, right. So basically this will give the general solution of this equation. This differential equation will give me the solution. Okay, I am talking about the planar force field, and the general solution of this equation is given by this particular expression. We are not going in the depth of this, the derivation of this. We will only be using it by solving eigenvalues and eigenvectors. So you have to simple fix in your mind, there is a particle, okay, that particle is moving in a planar force field. Now when this is happening, a linear differential equation is followed. The linear differential equation is x dash is equal to ax, and its general solution, which is given by this xt, okay, which is given by this xt, is a solution. It will give the position. This is the position of the particle. So basically I am talking about the position of a particle in a planar force field, and the position is given by this expression, which is a general solution of this linear differential equation. That's it. Now what is there in this xt? C1 and C2 are constant, lambda 1 and lambda 2 are the eigenvalues, and V1 and V2 are the eigenvectors. And at t is equal to 0 is considered as the initial situation. So they will give me this x0, that is the initial value of xt at t is equal to 0. This will help me to find out the value of C1 and C2. So what is a concept? How I will proceed for the formula or for the question? See, I am saying ki every question they will give me x0. Correct? X0 means the value of xt at t is equal to 0. Now just put t is equal to 0 here. What you will get? X0 is equal to C1 V1 plus C2 V2. Now what I will do in the questions, they will give me some x0. I will put here. Okay. Same way vector 1 and vector 2 will be given. I will put here. Right. Then I will get the value of C1 and C2. Solving this, we will get the value of C1 and C2. This value of C1 and C2 I will put here in my xt expression and I will get my answer. Correct? So let us start with the question. Let A be a 2 cross 2 matrix with eigenvalues -3 and -1. Means lambda 1 is equal to -3 and lambda 2 is equal to -1. And V1 is equal to -1, 1 and V2 is equal to 1, 1. Correct? This is given. Now, xt be the position of particle at time t. Solve the initial problem x dash is equal to ax, where x0 is equal to 2 and 3. Correct? This is given. Now I need to find out capital xt, that is my position. How I will proceed for this? As I know that what is the expression for xt? Xt expression is very simple. This is equal to, see, I'll write here again, C1, then e to the power lambda 1t into V1 plus C2 e to the power lambda 2t into V2. Now in the beginning at x0, when t is equal to 0, this will become C1 e to the power 0 is 1, so V1 plus C2 and V2. Correct? Now they have given that x0 value is 2, 3. So let me put 2, 3 is equal to C1. What is the value of V1? -1, 1. Plus C2. What is the value of V2? 1, 1. Right? So 2, 3 is equal to, this will become minus C1 plus C2 C2. Right? So this give me two equation, minus C1 plus C2 is equal to 2 and C1 plus C2 is equal to 3. Now solve these two equations. If you add these two equations, you will get 2C2 is equal to 5. So C2 is equal to 5 by 2. Now substitute C2 is equal to 5 by 2 here. So C1 is equal to 3 minus 5 by 2, that is equal to 1 by 2. Correct? Okay, so I got the value of C1 and C2. So now what is XT? XT is equal to C1. What is C1? 1 by 2 e to the power lambda 1. Now in the question, what is lambda 1 given? Lambda 1 is equal to minus 3. So minus 3, okay, T and V1. What is V1 now? V1 is given as minus 1, 1. So minus 1, 1. Right? Then plus C2. C2 is 1 by 2 e to the power lambda 2. Now what is lambda 2 value? Minus 1. So minus 1. And what is the other vector? Other vector is 1, 1. So if you want, you can leave this answer like this, or if you want to simplify it, you can simplify it also. Okay, you can make it as, write it as a matrix that, okay, 1 second, here T will also come. You can write it down as a matrix also, and you can leave this also as an answer. If you want to write it as a matrix, it will become e to the power minus 3t minus 1 by 2, and this you can combine it, right? I'll show you how. I'm saying minus e to the power minus 3t upon 2 plus e to the power minus t upon 2. And here e to the power minus 3t upon 2 plus e to the power minus t upon 2. Like this also we can write down, or this is also perfectly okay. Let's move to the next question. Now see, a particle moving in planar force field followed this. A has eigenvalues. Okay, so my first thing, lambda 1 is equal to 4, lambda 2 is equal to 2, V1 is equal to minus 3, 1, and V2 is equal to minus 1, 1. Correct? Find the position at time t if x0 is this. Now, we know that what is the solution? Xt solution is equal to C1 e to the power lambda 1 t V1 plus C2 e to the power lambda 2t V2. Correct? This is the formula. Now, in the beginning, at t is equal to 0, this will become C1 V1 plus C2 V2. Substitute the value. What is x0 value? X0 value given is minus 6, 1 is equal to C1. What is V1? Minus 3, 1 plus C2. What is V2? Minus 1, 1. Now, this will give me minus 6 is equal to minus 3 C1 minus C2, and 1 is equal to C1 plus C2. Now, if you solve these two simultaneous equations, you can directly use your calculator also to solve this equation, or manually also you can do, because it is easy. So, you will get C1 is equal to 5 by 2 and C2 is equal to minus 3 by 2. So, what will be my final answer? My final answer xt is equal to C1. C1 is what? 5 by 2 e to the power lambda 1t means 4t into V1 plus minus 3 by 2 e to the power 2t, and what is the vector? Minus 1, 1. Correct? So this is the answer. Here also, if you want, you can combine and write it as a column matrix, or you can leave it like this also. Right? So now come to the next question. Now look at the next question. Suppose a particle is moving in a planar force field satisfying x dash is equal to ax, x0 is equal to x0, a is equal to this, x0 is this, solve initial value problem. See, now this question is exactly the same as the previous two questions. The only thing, they have not given me eigenvalue and eigenvector. So by my normal procedure, I should find out first eigenvalue and eigenvector. So let us work on that. It is a 2 cross 2 matrix. So what is the characteristic equation? Lambda square minus p1 lambda plus p2 is equal to 0. Now in this question, what is p1? P1 is the sum of diagonal elements. So 4 plus 1 is 5. 4 plus 1. And p2 is what? P2 is the determinant value. What is the determinant value here? 4 ones are 4 minus 5 twos are 10. So minus 6. So p2 is minus 6. So what is my characteristic equation? Lambda square minus 5 lambda minus 6 is equal to 0. If you solve this equation, lambda is equal to minus 1 and 6. So lambda 1 I got, lambda 2 I got. Now let me find out the eigenvector. We have already practiced a lot eigenvectors. So what is the working procedure for that? Put lambda here, lambda here. Then xy is equal to 0, 0. Give me eigenvectors, correct? Now first lambda is equal to minus 1 I will take. When you take lambda is equal to minus 1, this will become 5, minus 5, minus 2, minus 2. Sorry, plus 2. Then xy is equal to 0, 0. So it give me 5x minus 5y is equal to 0, implies x by 1 is equal to y by 1. So my eigenvector x1 or v1, here we are using v1 is equal to 1, 1. Correct? Let's do for lambda is equal to 6. So now in place of lambda, I'll put 6. So 4 minus 6 is minus 2, minus 5, minus 2. 1 minus 6 is minus 5. Then xy is equal to 0, 0. Correct? So minus 2x minus 5y is equal to 0. So this give me 2x is equal to minus 5y. Correct? 2x is equal to minus 5y. And x upon minus 5 is equal to y upon 2. So what is my second eigenvector? That is v2. v2 is equal to minus 5 and 2. So I got my x1, lambda 1, lambda 2 and v1, v2. Once I got this, I know that in xt at t is equal to 0 is equal to c1 v1 plus c2 v2. Correct? And what is the value of this xt at t is equal to 0? What is the initial? 2.9 and 2.6. So I'll write 2.9, 2.6 is equal to c1, v1 is 1, 1 plus c2, v2 is minus 5, 2. Correct? So you will get c1 minus 5c2 is equal to 2.9 and c1 plus 2c2 is equal to 2.6. Now solve these two equations. You can use easily your calculator. So you will get c1 is equal to 94 by 35, which is equal to 2.68, and c2 is equal to minus 3 by 70, which is minus 0.04. Correct? Once you get c1 and c2, how you will write down the answer? xt is equal to c1, that is 2.6268 e to the power lambda 1. So what is the lambda 1 value here? So lambda 1 is minus 1. Minus 1 t and v1. v1 is 1, 1. Plus minus 0.04 e to the power 6t and second eigenvector is minus 5, 2. Correct? So this is my answer. If you want, you can again simplify it and write it as a matrix, or you can leave like this. So this is the basic application of eigenvalue and eigenvector when I talk about the planar force field. So only you have to remember the xt expression, and this simple method is there. It looks complicated, but it is very simple. I hope you understood it. If you have any doubts in any topic, let me know. I will upload the detailed video for that. If you like it, share it, subscribe it. Thank you.